The average age of the people in a group was 35 years before one of the members of the group left and was replaced by someone who was 12 years older. If the average age of the group is now 37, how many people are in the group? Let's have a look at the whiteboard and see if we can figure it out.
So as always, when tackling a word problem, our first step is to find the relevant pieces of information and lay them out in bullet point form. The average age of the original group was 35 years old. The average age of the new group was 37 years old. And the difference between the original group and the new group is that one person left and got replaced by somebody who was 12 years older. The next step is to translate these statements into mathematical statements that we can work with algebraically. Recall that the average of any set of numbers, whether they're ages or something else, is the sum of all the individual numbers divided by the total number of numbers. We're going to use that definition of an average to solve this problem. The average of our first group is 35. The average of the new group is 37. What was the difference between the original group and the new group? Somebody left the original group and was replaced by somebody else who was 12 years older. That means the sum of all of the people in the group has increased by 12. Now that we've got two equations in two variables, we're ready to start solving. I've rewritten our equation just a little bit, allowing s to represent the sum and n to represent the number. And I've highlighted n in blue because that is our goal. We want to know how many people are in the group. Solving for s first, we get s equal to 35n, and we can now use that substitution right here. After performing the substitution, it's just a little bit of algebra to get to the final answer. Multiply both sides by n, then subtract 35n from both sides. And on seeing that 2n is equal to 12, divide both sides by 2 and see that the number of people in the original group, and the new group for that matter, was 6.